Hello and welcome to ESE Electronics. Today's class we are going to see the questions from network analysis area. So this subject, that is network analysis, is very much important if you are going for ISRO scientist or technical assistant examination, because the maximum mark is allotted for this subject. This video is very important. So if you are preparing for any of this post, please do watch this video till the end. Okay. So let us see what is the first question. Find the equivalent resistance between node 1 and node 3. So this is the node 1 and this is a node 3. You have to find the equivalent resistance between these two nodes, that is node 1 and node 3. How to find the equivalent resistance? If you see these three nodes, that is node 1, node 2 and node 3 are connected in a star connection, right? So how to find the equivalent resistance between two nodes of a star connection? The only solution to do this is to convert the star connection to a delta connection. Okay, so we can convert a star connection to a delta connection like this. That is, if this circuit is a star connected circuit having resistance R1, R2 and R3, then we can form an equivalent network of this or connection with a delta like this. So this outer one is the delta and inner one is the star connection. So this will form your delta connection, and let the value of the resistors in the delta connection be RA, RB and RC. Okay, so we have replaced this star connected network with a delta. Now this delta network is relevant because we are going to replace the inner star connection, and the outer delta connection is having resistors RA, RB and RC, and the value of RA, RB and RC will be like this. The value of RA is equal to we are going to replace this star connection, right? So this RA value will be in terms of R1, R2 and R3, and it will be like this: R1, R2 plus R1, R3 plus R2, R3 by, see this is RA, and take the opposite resistance, this is R3. Okay, so this is the value of your RA. Now the value of RB will be, RB is equal to, again the numerator is same, R1, R2 plus R1, R3 plus R2, R3 by, we are going to take RB resistance, right? So here is RB and the opposite resistance is R2. So this is the value of your RB of your delta connection. Now the value of RC is RC equal to R1, R2 plus R1, R3 plus R2, R3 by, this is RC and the opposite resistance is R1. Okay, so this is how the value of the RA, RB and RC will vary. Now we can remove this star connection because we have formed an equivalent delta connection. So if this is node 1, this is node 2 and this is node 3, see this resistance is the equivalent resistance between node 1 and node 3. Now if you see this question, they have asked the equivalent resistance between node 1 and node 3, right? So if you perform this conversion, you can do, or you can find the value of equivalent resistance. Okay, so I'm going to convert it to a delta connection. I'm not going to find the value of all the three resistances. Only one resistance is equivalent because we are going to do this problem in competitive exam. We don't have time to do all these conversions. We only need this equivalent resistance, right? So let us write the equation for that. So let us assume this is your RA, right? So I'm going to take only this resistor of my delta connection. Okay, so how will be the value of this RA? RA equal to, I've just called it as RA. Okay, so RA will be equal to, this is 11 ohm, this is 10 ohm and this is 10 ohm. So 10 into 11 plus 10 into 10 plus 10 into 11. That is, this is R1, this is R2 and this is R3. Substitute in the general equation by this is the RA resistance and the opposite value is a 10 ohm, right? So divide by 10. So if you take this, it is 110 plus 100 plus 110 by 10. That is 320 by 10, or which is equal to 32 ohm is the equivalent resistance between the node 3 and node 1, or node 1 and node 3. Okay, so the equivalent resistance between node 1 and 3 is 32 ohms. Okay, so 32 ohms is your correct answer, and the correct answer for this question is option C, which is 32 ohms is the correct answer. The next question is, determine the current through all resistors. So there is a connection of 3 resistors in parallel, and also the circuit is having a current source of 50 ampere. Okay, so you need to find the current passing through these 7 ohm, 3 ohm and 5 ohm. So the options given are A, 2 ampere, 4 ampere, 11 ampere, B, 5 ampere, 4.8 ampere, 9.6 ampere, C, 9.3 ampere, 26.22 ampere and 11 ampere, and D, 10.56 ampere, 24.65 ampere and 14.79 ampere. So how to solve this network? So if you see, all the 3 resistors are connected in parallel connection, right? And we know that when resistors are connected in parallel connection, the voltage across these 3 resistors will be equal, because in parallel connection the voltage is same, and in series connection the voltage will vary. Okay, so if you take the voltage across 7 ohm, 3 ohm and 5 ohm as V, let V be the voltage, because all the values are equal, we are taking it as V. And the current flowing through the 7 ohm, let it be I7. I7 is equal to voltage by resistor value, which is 7. Again, I3, which is a current flowing through 3 ohm, which is V by 3. Again, for 5 ohm, I5 is equal to V by 5. Right. So the currents are I7, I3 and I5. Now, if we apply the Kirchhoff current law, we know that this 50 ampere is being split across 7 ohm, 3 ohm and 5 ohm, right? So if you apply the Kirchhoff current law across this node, the current is being split across these 3 resistors. That is 50 ampere is being split. Okay, so you can write the equation as 50 ampere is equal to I7 plus I3 plus I5, right? So 50 ampere is equal to I7 is V by 7 plus V by 3 plus V by 5. Now if you solve this, the value of V is obtained as 73.94 ampere. Sorry, volt is the value of voltage obtained. Okay, so if you have this voltage, you can find the value of current through all the resistors, right? Because we know that the current I7 is equal to V by 7 and I3 equal to V by 3, I5 equal to V by 5. So substitute the value of V in these equations and we can find the value of current, right? So I7, or the current through 7 ohm, is 73.94 volt by 7 and it is obtained as 10.56 ampere, and I3 is equal to 73.94 by 3, which is 24.65 ampere, and I5 is equal to 73.94 by 5, which is equal to 14.79 ampere. So this question is actually an application of Kirchhoff current law. So you have to first identify that how to solve this question. That is, you have to think how to find the value of the current through these resistors. So since there is only a single current source, you can think of Kirchhoff current law, because the current will anyway split through these resistors or no. Okay, so the correct answer for this question is option D, which is 10.56 ampere, 24.65 ampere and 14.79 ampere is the value of current through 7 ohm, 3 ohm and 5 ohm. Okay. resistance of a wire is YO. The wire is stretched to triple its length. Then the resistance becomes dash. This is a very simple question. You should know the basic equation for resistance. R equal to resistivity rho into L by A. So this is the original resistance. Now what is being changed? The length is that is the wire is stretched to triple its length, means length is made as thrice. So R dash is equal to rho into, rho is same, L is made as 3L by A. So you can write this as this equal to 3 into rho L by A, that is 3R. So how will the R change? R dash is equal to 3R. Now it is given that the resistance of the wire is YO. So R dash is equal to 3Y will be the new resistance if the wire's length has been stretched as thrice. Okay, so the correct answer for this question is option B, which is 3Y is the answer. Okay, next question. A copper wire of length L and diameter D has a potential difference of V applied across its ends. The drift velocity V will change how when the diameter is made as D by 4. Here the drift velocity is V, and the drift velocity, how the drift velocity will change if the diameter is made as D by 4. Okay, I'll remove it and I'll write it here. So the equation to find the drift velocity is V equal to I by N into A into Q. Since we are using a copper wire, we can write this A or area in terms of the diameter, that is N into pi into D by 2 square into Q. Right, so this is your original drift velocity. Now in this question it is given that the diameter is made as D by 4. So how the drift velocity will be changing? So V dash is equal to I by N into pi into D by 2 is made as D by 4, that is diameter is made as 1 by D by 4. We have changed. Okay, so into 1 by 4 square into Q, right? So we can write this as, I'll take this 1 by 4 square outside. So D by 2 the whole square into Q into 1 by 4 square is 16, right? So you can write this as your original drift velocity, which is V. So it is a V by 1 by 16, or 16V will be your new drift velocity. So when the diameter of your copper wire or the conductor is being made as D by 4, the drift velocity will increase by its square times. That is, if it is D by 4, then it is 16V will be your new drift velocity. Okay, so the correct answer for this question is option B, which is 16 times the drift velocity will increase, or 16V. The next question is, a 25 ohm resistor has a voltage of 150 sine 377t. Find corresponding power. Okay, so the options given are A 900 sine square 337t, B 90 sine square 337t, C 900 sine square 377t, and D 9 sine square 337t. So the equation to find power is, either you can use the equation P is equal to V square by R, or P equal to V into I. So since the question is having voltage and resistance, we can use this equation. So the value of V is 150 sine 377t by, the whole square by the resistance R is 25, right? So it is 150 into 150 sine square 377t by 25. So dividing it, you will get 30 into 30 is 900. Okay, so 900 sine square 377t will be your power. Okay, so don't skip this question by seeing a angle term with your voltage. This is a simple question. You can directly apply this voltage to the equation P, power is equal to V square by R, or you can use this equation V into I by first finding the current value. Okay, so the answer for this question is option C, which is 900 sine square 377t is the value of your power for this voltage and resistance. Okay, so these are the questions which I have included in this video. We'll be seeing in the next part with more questions. We'll be doing 3-4 parts of the network subject because it is a vast subject and maximum mark is being given to a network and other core subjects. Okay, so if you found this video useful, please do like it and share this video with all your friends. And if you want more videos, please do subscribe to the channel. Thank you.